Good morning, dear students. My name is Ferhan Mazher, and today is 28th of March 2021. And the subject we are studying is Physics 504. And today we have set our heart to solve October-November 2014 paper. Today we are solving a MCQ paper. The number of the paper is 1-1. This is a MCQ paper from the Zone 1. We call it paper 1, and let's start this paper. Hopefully, this will be helpful to you. And let's start. Question number 1. Now, force of 25 Newton and 40 Newton acts on an object in the direction shown. Which arrow shows the direction of the resultant force? Here you can see we have been given two forces, 25 Newton force and 40 Newton force. And we want to find out what is their resultant because these are two vectors. And if you want to find out their resultant, we will use the parallelogram law to find out their resultant. When you want to add two vectors in the parallelogram law, we put these two vectors in such a way that their tails are joined. So for this purpose, we will, I have done this on a paper. Let me show you my work. So it will become very easy for you. So here you see that I have drawn two vectors, 25 Newton and the other force, and I want to find out their resultant. And what I will do, I will place them in such a way that their tails are joined. And then I will suppose that they are the adjacent sides of a parallelogram, and I will complete that parallelogram. Then where the tails are joined, I will join that point with the opposite corner of the parallelogram, and that will be the resultant. Here with the red line, I have shown the resultant. This is the complete parallelogram. Here is the point where the tails are joined, and I have joined it with the opposite corner. So this is your resultant. So let's see what is the options, what the options we have. So I think that B will be the right option. Question number 1, B is the right option. So the next question on your screen, which device can be used to measure the thickness of a single sheet of paper? A single sheet of paper is very thin. So for that purpose, the micrometer will be the best option. For measuring the thickness of a sheet of a paper, the micrometer is the best option. Question number 2, B is the right choice. In a test, 4 students link the quantities on the left with their units in the right. Which student matched matched them all correctly? Frequency, the unit is hertz. The acceleration, it should be meter per second square. The latent heat is joules, and the power is watt. So I think the A is the right choice. The speed time graph represents a short journey. Here is a speed time graph, and you can see the speed is uniformly increasing. And he says it means the speed is changing basically, but it's changing uniformly. The speed is increasing. Which distance time graph represents the same journey? So here we have 4 distance time graph. Here the speed is increasing. So the distance time graph must be an increasing curve. The distance time graph must be an increasing curve. So A is the right option, sir. Question number 4, A is a distance time graph. whose gradient is gradually increasing curve. A boy sits on a playground roundabout. A roundabout carries the boy in a horizontal anti-clockwise circle at a constant speed. The diagram shows the view of the roundabout from above. What describes the resultant force on the boy? The direction of the resultant force should be always towards the center of the circle when you are moving in a circle. The D is the best option. The resultant force is in the direction of the Y. So, sir, D is the right option. A scientist places a rock on a spring balance. She then places the same rock on a beam balance. At the North Pole, the gravitational field strength is greater than at the equator. She performed the experiment at the North Pole and at the equator. How do the reading at the North Pole compare with those at the equator? You see, the reading of the spring balance should change because it is measuring the weight, and the mass. The beam balance reading should remain the same because it's measuring mass. The mass do not change with the change in the location, but the weight value changes because the weight depends upon the gravitational field strength, and the value of the G at the North Pole is different, and the value of the G at the equator is different. So the spring balance reading will be different at the North Pole, but the beam balance reading will be same. So spring balance reading different at the North Pole, and the beam balance reading should be the same at the North Pole. So I think B is the best option. Question number 6, B is the right option, sir. What affects the stability of an object? It says only its base area and the location of the center of the mass. This is the correct option. Only its weight and its base area, no. Only the location of center of mass, no. Only its weight, no. So A is the best option. The body will be more stable if its base area is large and the location of the center of mass is lower. Which objects behave as an elastic solid as it deforms? You see, you applied the force and the shape of the body changes, and then it will come back to its original shape. So where this happens? A football as it is kicked. Sorry. D is the right option. By mistake, I have highlighted the whole thing. And D is the right answer. Question number 8, D. D is the right answer. It's a very, very important question. A spring extends by 6 centimeters when a 15 Newton weight is suspended from its lower end. So if you take a single spring and you hang 15 Newton load, the extension produced will be 6 centimeters. 3 of these springs are used as shown in the support of 90 Newton weight. So when you have hung these springs parallel to each other, there are 3 springs you are using, and you hung a 90 Newton load. So the load will be distributed equally on them. So each spring will be experiencing 30 Newton load. So if the 15 Newton load on a single spring produces 6 centimeter extension, if the single spring will be experiencing 30 Newton load, how much will be the extension? So let me show you my work. Load is 90 Newton. So the load on the one spring. Each spring will be 90 divided by 3, 30 Newton. So a single spring will be experiencing like 30 Newton. Extension and load, I'm going to use the proportion method. So 6 centimeter extension when the load is 15 Newton. When the load is 13 Newton, the question is how much is the extension? So 6 divided by x equals to 15 divided by 30. So cross multiply and x value will be 12 centimeter. So the extension in the springs will be 12 centimeter. So B is the right option. Objects of different weights are placed on a rigid horizontal surface. Which row shows the correct pressure acting on the surface? So here the weight is given, the area is given. I will calculate the pressure. Pressure will be force divided by area. So we will check which the pressure which he gave, which one is correct one. So the pressure is equals to force divided by area or weight divided by area. So for all the four options, I will calculate the pressure, weight divided by area. For example, the first one I have done is 10 divided by 0.1. Same I will do with all the four options. So I calculated the pressure. First one is 100 Pascal, 100 Pascal, 300 Pascal, 200 Pascal. So C is the right answer because he also gave 300 Pascal value. The diagram shows a simple manometer that contains a liquid. The side X is connected to a gas supply of pressure R. Side Y is open to the atmosphere at the pressure S. Which pressure is the length H used to measure? You see, here is the gas pressure and here is the atmospheric pressure. The gas pressure is clearly larger than the atmosphere pressure because the level of the mercury in the side where you have the gas is lower and the level of the mercury on the atmospheric side is higher, and the difference between the levels in both the limbs is H. So the pressure of the R and the pressure of the S, R is more and the pressure S is lower, and R minus S will be equals to H. So H will be basically R minus S. So question number 11, C is the right option. Air is trapped in a cylinder by a piston. The pressure of the air is P and the length of the air column is 20 centimeter. The piston is moved outwards until the length of the air column has increased by 40 centimeter. The temperature of the air remains constant. What is the new air pressure? One thing which you should know, because this is cylinder and its volume, the volume of the cylinder is cross-sectional area multiply length of the air column. The volume of the air inside the cylinder, it can be found by the formula cross-sectional area multiply length of the air column. Here you see the temperature. He says the temperature of the gas remains constant. So I can apply the formula P1 V1 equals to P2 V2. Let me show you my work. P1 V1 equals to P2 V2. P1 is P, volume 1 will be area multiply length 1 equals to P2 is the question, and area of the cross section will be still the same, A multiply the length of the column L2. A and A will be cancelled from both the sides. P1 is P, A is sorry, L1 is 20 equals to P2 is question, and the L2 is 60. So P2 will be equals to 20 P divided by 60. So P by 3. So P2 will be P by 3. P by 3. B is the right option, sir. A student uses a Newton meter to pull an object horizontally along rough ground. The student multiplies the Newton meter reading by the distance traveled, distance moved by the object. How does this, what does this calculation give? The Newton meter giving you the value of the force, and when you multiply force with the distance you move the object, that give you the work done. Question number 13, D is the right option, sir. A builder carrying 6 bricks climbs a ladder. So he's talking about how many bricks? 6 bricks. Each brick weighs 25 Newton, and the builder climbs a vertical distance of 4 meter in 8 seconds. 4 meter in 8 seconds. What is the average power used? Okay, so the power will be equals to the work done divided by time, and the work done will be weight multiply height, and you divide it with the time, you get the power. I've done this on a paper. Let me show you my work. So the power is equals to work done divided by time. The work done, because you are taking it vertically upward, that will be weight into the vertical height divided by time. So 6, because there are 6 bricks, each brick is 25, and you multiply with 8, 6 multiply 25, and multiply 4 divided by 8, and 75 watt will be the answer. Let me check it again. 75 watt. So question number 14, B is the right option, sir. A copper rod is heated at one end. Which statement describes how the heat is transferred? The heat transfer occurs in the copper. In the copper, because the copper is solid. In the copper, both methods are used of the conduction. One method is by the vibration of the molecules, and the second one is the free electron diffusion. In the free electron diffusion, the free electrons at the hot end absorb the energy, and they go to the cold end. They collide with the molecules there and make them vibrate vigorously. So I think D is the right option. That the energetic free electrons move from the hotter end to the cooler end. So I think D is the option. Question number 15, D is the right option, sir. The diagram shows a clinical thermometer. Which factor affects the sensitivity of the thermometer? The sensitivity of the thermometer depends upon the diameter of the bore. A very famous MC. Question number 16, B is the right option, sir. A centimeter scale is fixed next to an unmarked mercury in glass thermometer. The ice point and the steam point are marked. What is the temperature shown on the thermometer? Okay, so the length of the ice point is 1 centimeter. So L naught will be 1 centimeter. The length of the steam point is 11. So L naught, L100 will be 11. L theta is 6.6. So the temperature is the question. I've done this numerical on a paper. Let me show you. You should remember this formula: L theta minus L naught divided by L 100 minus L naught equals to theta divided by 100. Very famous formula. So L theta is 6.6 minus 1 and divided by 11 minus 1 equals to theta divided by 100. 5.6 divided by 10 equals to theta divided by 100. So theta will be 56 centimeter. A very, very, very important formula, a very, very, very important numerical. Never forget this. So the temperature is 56. So B is the choice. Water is poured into 4 dishes. In 2 of the dishes, the water has a small surface area, and in the other 2, it has a large surface area. The water in the 2 of the dishes is cool, and the water in the other 2 is warm. From which dish does the water evaporates the quickest? The water will be evaporating quickest from the dish whose surface area is large and whose temperature is warm. So I think question number 18, B is the right option, sir. A wave of frequency 13,000 hertz travels 1300 meter in 4 seconds. What is the wavelength of the wave from this distance given and the time given? Divide the distance with the time and you will get the speed, the value of the V. And the frequency is also given. Then I will apply the formula V is equals to F lambda, and from there we will find out the wavelength. I've done this on a paper. Let me show you my work. So the velocity will be the distance traveled divided by time, 1300 meter divided by 4 seconds. 325 meter per second is the speed. B equals to F lambda 325 divided by, so 325 equals to 1300, and lambda will be equals to 325 divided by 13,000, 0.025 meter, 0.025 meter. Very important numerical. Question number 20, question number 19, A is the right option. A shoe shop puts a mirror on the wall so that the customer can look at their shoes. The length of the mirror is 50 centimeter. A customer has eyes 150 centimeter above the ground level. The bottom of the mirror is at a height h above the ground. What is the smallest value of h that allows the customer to see an image of his shoes in the mirror? Okay, it's a very tricky one. So let me show you. So this is the original mirror which they have shown, and the height of the man is 150. So I have found what is the midpoint of this 150. So it's approximately here. So I brought it here. I started a ray of light from the toe of his shoes, and here it is reflected and it will go into the person's eye. The angle of incidence and the angle of reflection, they both will be equal to each other. So the reflecting surface of the mirror must be here. You see this all, and this is also the middle of the mirror. The mirror is 50 centimeters. So you can move this mirror downward, and the top of the mirror can come here. Even then, the light will be reflected if the top of the mirror is at this point. If the top of the mirror is at this point, I have shown it here. Here you can see if the mirror is 50 centimeter, if the top of the mirror is at this blue line here, this should be actually here, the light will be reflected from this top point. So if the whole mirror is below this blue line, the mirror is 50 centimeter, the height of this blue line is 75, half of the 150. So this gap here will be only 25 centimeter. This is the question. How much will be this gap? He's naming it as H. This will be 25. So hope you have understood this. So let's check. The value of the H will be 25 centimeter. The B is the choice. Question number, I think question number 20B is the choice, sir. The diagram shows light traveling through a medium. The light reaches the boundary with a vacuum as shown. The light emerges traveling along the surface. What is the refractive index of the medium? So see, the light is traveling in some medium which is obviously dense as compared to the vacuum. So the light, when tried to came out, it has started moving on the surface of the two mediums. So the angle of refraction here is of 90 degrees. I've done this on a paper. Let me show you my work. So you can see here I have drawn a normal also. The angle of incidence is 30. The angle of refraction is 90. The n value can be found, in the formula. N equals to sine. It could be either sine I by sine R, or it can be sine R by sine I. We upstairs, we always put that angle which is in the rare medium. A very important point. In this formula, upstairs or in the numerator, you always put that angle which is in the rare medium. So in this case, vacuum is the rare medium. So angle in the vacuum, that is angle of refraction, that is of 90 degrees. So the n value will be sine 90 divided by sine 30. Sine 90 divided by sine 30. Sine 90 divided by sine 30, C is the option. The diagram shows an object on the principal axis of a converging or convex lens. Principal focus of the lens is at F. And where is the image formed by the lens? So I've done this on a paper. Let me show you. So you can see to locate the image, I have started this first ray, which is of red color. I started it from the head of the object, and this moves parallel to the principal axis. After passing through the lens, it will pass through the F. The second ray, I started from the head of the object and passed through the optical center, and it goes undeviated. This I have represented with the blue light. Then I have used the third ray, which passes through the F on the same side. The F is 4 squares. So 1, 2, 3, 4. So here is the F on the same side where you have the object. I started the ray. This is orange color ray. Started from the head of the object. It passes through the F. And when it touches the lens, after passing through the lens, it becomes parallel to the principal axis, where all these three lines intersected. There you will be, there the image will be formed. So I have shown the image with the green color line here. So you can clearly see that the image is on the right side of the Q. The image is on the right side of the Q. So D is the right option. The image is formed to the right of the Q. A digital camera uses a lens to produce a diminished image on a light sensor. Which row shows the correct type of lens and the nature of the image? You see in the camera, we use a converging lens, and the image formed is real, it is diminished, and it is inverted. So we will be using a converging lens, and the nature of the image will be inverted. Question number 23, A is the right option, sir. Which application uses microwaves? Microwaves are used in the satellite television. A very simple fact which you should remember. Satellites use microwave. D is the option. A star explodes in outer space. Which waves from the exploding star do not reach the Earth? The sound which is produced cannot reach the Earth because between the star and the Earth we have space, we have vacuum, and the sound cannot travel through the vacuum. The question was, which waves do not reach the Earth? Sound waves. A metal bar PQ hangs from a thin thread and always comes to rest with the end P pointing north. It means it's a magnet. Another bar XY of the same metal settles in no definite direction. So it means it's not magnetized. What happens to the two bars are brought near to one another? The X is a magnetic, it's not a magnet, whereas the P and the Q, it's a PQ is a magnet. So end P and the end Q both are attracted to the X. That is 100% possible. That is possible. And P attracts the end X but repels the end Y. That is not possible because the XY is not a magnet. So there will be no repulsion. The end P neither attracts nor repels and X. Uh, we are and and P repels and X but attracts. Repulsion cannot be there because both of them made up of the same material. So probably they both are made of the steel. So attraction should be there. The steel should be attracted to the magnet, but repulsion cannot be there. So I think A is the best option. Question number 26, A is the best option. The diagram shows a 12-volt DC power supply connected across a coil with a metal core. The core becomes a magnet when the current is switched on. It remains a magnet after the current is switched off. From which metal is the core made? The core of the metal core should be made of the soft iron because soft iron is soft magnetic material. It becomes a magnet, and when you stop the current, it immediately loses its magnetism. So C is the best option. The core becomes a magnet when switched on. It remains. Oh, sorry. I read the sentence by mistake. I read the sentence wrong. The core becomes a magnet when the current is switched on. It remains a magnet after the current is switched off. So the soft iron cannot be the answer because soft iron loses its magnetism immediately. So the right option will be D. You know that D is the right option because D is hard magnetic material. Once it becomes magnet, it retains its magnetic properties for a very long time. So steel is the answer. D is the right option. Question number 27, D is the right option. And why we have not chosen iron? Because of this sentence, it remains a magnet after the current is switched off. It retained its magnetism. So it is steel. D is the right option. With the component X, with the component X placed in the circuit below, the brightness of the lamp can be gradually reduced until it goes out. What is the component X? So what you can put here? A read relay. Read relay is only a switch. It cannot reduce the brightness of the lamp. It can on it, it can off it, but it cannot gradually reduce the brightness. A switch, no, switch can only on it, off it. It cannot gradually decrease the brightness. A transformer cannot do this. Plus, the transformer don't work on the DC power. A variable resistor, yes. If you connect a variable resistor here, when you will gradually increase the resistance of the variable resistor, it will take lot of voltage. The voltage supplied to the lamp will decrease, and the lamp will become dim and dim and dimmer and dimmer. So D is the choice. Which circuit is connected correctly to measure the current in a fixed resistor? We want to measure the current in the fixed resistor and the potential difference across the same resistor. So you want to find out the voltage drop across a fixed resistor. So you will have to put a voltmeter parallel to that fixed resistor and an ammeter in series with the fixed resistor. So C is the best option, sir, clearly. The diagram shows a current carrying wire in a horizontal magnetic field. Which row shows the direction of the force experienced by the wire? You see, you can use your left hand rule, Fleming's left hand rule. This is my left hand. M as FMC. FMC. Magnetic field, the force, the magnetic field, and the current. You see, this thumb is force, this index finger is magnetic field, and this middle finger will be the current. You stretch them in such a way that they are perpendicular to each other. Left hand rule. So what I will do, I will stretch the magnetic field is towards the right side. The current is coming towards me. So you can see my thumb is pointing upward. So by using the left hand rule, I can tell you that the direction of the force will be B. Question number 30, the direction of the force will be B. I have used the left hand rule. And remember, FMC. This thumb is F. This index finger is M. And this middle finger is C. F means the direction of the force. M means the direction of the magnetic field, and C means the direction of the current. So I applied this. The current is towards me. The magnetic field is towards right. My thumb is pointing upward. It means that the force experienced by this conductor will be in the B direction, upward. The diagram shows a DC motor with its coil horizontal. Why is a split ring commutator used? You see the split ring commutator, when the coil becomes vertical, it reverses the direction of the current in the coil. This is the function of the split ring commutator is to change the current direction in the coil as the coil passes the vertical position. So question number 31, B is the right answer. It's a very, very famous question. Which graph shows the voltage output of an AC generator? In the AC generator, the waveform goes up and down, up and down, up and down. It becomes positive, then negative, positive, negative. Very simple question. D is the right option, sir. An electric current flows through a thin metal filament in a vacuum. The filament emits particles. Which particle is emitted and what is its charge? You know, he's talking about the CRO, and when the metal filament is heated, it gives out electrons. We call it the thermonic emission. The electrons come out and the charge on the electrons is negative. So A is the option. He's talking about thermonic emission. Particles will be electrons and the charge on them will be negative. So here he has shown a potential divider, and this is the R1, this is the R2, the V out is given to a motor. So here we have a variable resistor in the position of R1. In the circuit shown, resistor X and Y act as a potential divider to control the speed of a motor. What is the reason for the potential? What is the reason for the potential divider? With the help of the potential divider, we can control the voltage which you have provided to the motor to vary the potential difference across the motor. Yes, that is the purpose. This is why we use the potential divider. So 34, C is the right choice. In the circuit shown, R is a light-dependent resistor. Its resistance decreases when the intensity of the light shining on it increases. The light intensity on the R increases. What happens to the brightness of the two lamps L1 and L2? Try to understand this. This branch and this branch, they both are connected parallel to the battery. So in this branch, the voltage drop, the total voltage drop equals to the EMF of the battery. On this branch, the total voltage drop will be equals to the voltage of the EMF of the battery. The resistance of the lamp L1 has not changed, and the voltage drop is equals to EMF. So the power here has not changed. So the lamp will be at the normal brightness. So the lamp 1 will remain at the normal brightness. Now, if you look at this branch, when the light will be falling on it, the resistance of this has become less. When it will be in the light intensity has increased, the resistance R has decreased. When the resistance will decrease here, so what will happen? It will take less voltage. So the voltage drop here will increase because now its resistance has decreased. So the it will take less voltage, so the lamp 2 will take more voltage. It will have to take more voltage because the resistance of R has decreased when the light is shining on it. So its resistance will decrease. When the LDR resistance will decrease, it will take less voltage, so the L2 will have to take more voltage. So the L2 its brightness will become more, but the resistance of the L1 will remain the same, whatever was it before. Question number 35. D is the option. You know, the brightness depends upon the power actually. In the L1, the voltage was same, the resistance is same, so the current will be also the same. So the power is same in the L1. So it will remain at its normal brightness, whatever it was before. But when the light will shining on the R, its resistance has dropped. So the total voltage drop here, the voltage is divided between these two. So now when its resistance will decrease, it will take less voltage. So the L2 will have to take more voltage. So because it will take more voltage, it will become more brighter. Because the power here, whatever power it was using before, now it will be taking more power. D choice, a little tricky question. What is a reed relay used in switching circuit? You see, the use of the reed relay is because the reed relay will be working on a very small current. A very small amount of current is required to operate the reed relay. And with the help of the reed relay, we are able to switch on and off a very large current. A switch on a small voltage using a large voltage, or a switch on a large current using a small current. Yeah. Switch on a large voltage using a large current. No, this is the option. C is the option, sir. 36C is the option. The relay, the current which is used to operate the relay is very small, but with the help of this, you can operate on and off a current whose amount is large. So C is the right option. Three types of radiations emitted by unstable nuclei are electrons, helium nuclei, and electromagnetic radiation. What are these types of radiations? Electrons, they are beta particles. Helium nuclei, we call them alpha particles. And electromagnetic radiations, they are gamma rays. So C is the right option. The electrons are beta particles. Helium nuclei are alpha particles, and electromagnetic radiation is the gamma. So C is the right option. The energy emitted by the sun is released when the nuclei of an element fuse together. Which nuclei, when fusing together, release most of the energy in the sun? You see, we have two hydrogen nuclei, small hydrogen nuclei. They come close to each other, they fuse into each other, they make a larger nucleus of helium. This is called fusion. This is happening on the stars and on the sun. So the smaller hydrogen nuclei fuse together. So C is the option. A sample of wood contains 9 expo 16 nuclei of the carbon 14. The nuclei undergo radioactive decay with a half-life of 5,600 years. How many carbon 14 nuclei remain in the sample after 16,800 years? Okay, let me show you my work. I've done this on a paper. So I have drawn this famous grid of the half-life. At the start, there were 9 expo 16 carbon present. When one half life has passed, means 5,600 years. So the carbon atoms will become half. When another half-life will pass, 11,200 years. This will further half. And once 16,800 years have passed, means 3 half-lives have passed, it will further half 1.125 expo 16. 1.125 expo 16. I think this is the option. 39B is the right option, sir. How many nucleons in one neutral atom of krypton? Nucleons. Nucleons mean the mass number. The number of protons plus the neutrons. That is 84. Simple. Question number 40C is the option, sir. So, my dear students, today, today we have done October, November 2014 paper with the subject we are studying is Physics 505411. This was a Zone 1 paper. It's an MCQ paper. Today we have done a paper 1. My name is Ferhan Mazher and I hope that this video is helpful to you. And if this is helpful to you, kindly don't forget to subscribe my channel and also press the bell icon, also press the like buttons and also comment. So your support will be an energy for me. So I hope you will recommend these videos to your friends so they can also improve by sitting at their home, by watching these videos. They can practice the past papers of physics O level 5054. So I hope that this is very helpful to you. So thank you very much, everybody. And have a good day and God bless you all.